So now that you also got an introduction to services and dependency injection, you really have a solid foundation about all the core Angular essentials every Angular developer needs to know. Before we conclude this module though, there's one last little enhancement that we could make to this application, because at the moment it works such that all the changes we make, all the tasks we add or we mark as completed, are lost whenever we reload. Because we're only working with some dummy data that's stored in memory and that's always recreated when the app restarts, therefore. And we could improve this app by storing at least the tasks in a more persistent storage. Now, later in the course, you will learn how to connect your Angular application to a backend, so to a server where data could be stored in a real database. But for the moment here, I'll just store that data in the browser storage, which is better than nothing, I guess. So the idea is to fetch the tasks from the browser storage when the app loads, and to update the tasks stored in the browser storage whenever we add or remove a task. And I'll start with the initialization. For that, we can add a constructor here to this tasks service, because as you learned, that's a function that's automatically executed when the app starts. And in there, we could set this tasks array equal to data that we fetch from local storage. Now I'll actually do that with help of a helper constant, where I reach out to local storage, and where I then call getItem to get some data from local storage, which should be stored under a key of tasks. So the assumption is that in the browser's local storage, we're storing some tasks with a key of tasks. Next, I want to check if some tasks were found, and if I did find some tasks, so if some data was stored there, which will not be the case when we run this code for the first time, but if we do have some tasks, then I want to overwrite my tasks here with the tasks from local storage. However, the tasks we retrieve from local storage, this constant here, will always be a string, because we can't store complex values like arrays or objects in local storage like this. Instead, we have to convert them to JSON first, which in the end is a string that has a certain format. So the assumption is that the tasks, if they exist, will be stored in that JSON format, which is a standard format in programming. And therefore here, I'll actually parse the tasks as JSON to convert them back to an array. That's the idea here. So I keep my dummy tasks if no tasks are found, but if tasks are found, I'll use those instead. That's the idea here. Well, and now we need to update the tasks whenever we save or remove a task. And therefore, I'll add another helper method here, a private method, which is only meant to be used from inside this service class, which I'll name saveTasks. And here, I will simply call local storage setItem and set an item with a key of tasks, because that's also the key we're looking for when retrieving the tasks here. And I want to store my tasks array here. So I will now use JSON stringify to convert this tasks, the tasks array that's currently managed by this service, to such a string in the JSON format. And that will then be stored in local storage. And now we just have to call this saveTasks after removing a task and after adding a task in both places. Well, and with that, if you now save that and reload, you'll see the tasks are still there. But if I now complete a task and I therefore change my tasks, you can see, if you use the browser developer tools and you go to the application tab, that under local storage, there is a tasks key here, and the value under that key is now actually this string with the tasks in this format. It might not look like a string, but it is stored in a string in the end. So the data is stored, and therefore indeed, if I reload, we can see that for Marcus here, we only have one task now, because we're now using the tasks that are loaded from local storage. And this isn't an Angular specific feature or anything like that, but I think it's a nice enhancement for this first demo app here, which now allowed us to explore all those crucial Angular essentials every Angular developer must know. So in this section, you now learned a lot about Angular. You actually learned all about the crucial essentials every Angular developer must know. You learned about components, why they matter, and that the idea is that you build potentially complex user interfaces with components. And you learned how to create components, that they're classes that are decorated with that component decorator, which then holds the configuration for a component, like its identifier, you could say, its selector, but also where to find the template or styles of a component, because a component in the end is a custom HTML element, you could say. And the idea then is that you can use that element in the templates of other components, so that you're building a component tree in the end. Now, these components can then also talk to each other with help of inputs and outputs. Inputs are in the end properties of a component that can be set from outside that component, so from inside the parent component, which uses the other component in its template. And outputs are in the end custom events that can be emitted and that can also contain data, so that a child component can talk back to its parent component and let it know about something that happened inside of it, which is a crucial feature. Now, since things are happening in an Angular app, users might be clicking buttons and so on, it's also quite common that data changes in your Angular app. And therefore, you might want to output that dynamic data in the templates of your components, which you can do with various template binding syntaxes, like with string interpolation, which can be used to, for example, output the value stored in a property of your class. Or if you want to set a property of some DOM element, like the source of an image, you can do that with property binding. If you want to listen to events, no matter if they're custom events or built-in events, you do that with event binding, where you use these parentheses around the event name, and you then define the code that should be executed when the event occurs. By the way, a special kind of binding is two-way binding, which is typically used in conjunction with form inputs, which is unlocked by using this special two-way binding syntax on properties that support it. Most properties don't, but one property that does is the ngModel property, which is offered by the ngModel directive, which is available once you imported and unlocked the forms module. You can then use the ngModel directive with its two-way binding syntax to set up this two-way communication on an input element, for example, which allows you to listen to changes whilst also being able to send back data into the input to update it, for example. Now, coming back to data that changes, it's worth noting that by default, Angular watches for possible events that could lead to data changes and therefore UI changes automatically with help of an internal package called Zone.js. And therefore, by default, all you have to do if you want to update the UI is change some data, for example, after a button click, and output that data in the template with help of one of the template binding features. And Angular will figure out the rest, which is pretty convenient. You can, however, also use signals instead, where Angular is not automatically watching for all kinds of events that could lead to changes, but where you instead explicitly notify Angular about changes by, for example, calling the set method on a signal value, and where Angular sets up a subscription whenever you read a signal so that it knows which places of your app are interested in those data changes and should potentially be updated. And this, whilst being a bit more work for you, the developer, can therefore be a more efficient state management mechanism and can potentially potentially lead to better performance. Though this signals approach is only available since Angular version 16, and therefore in older Angular projects you, for example, can't use it. Now, it's also quite common that, for example, when some data changes, you wanna render some content conditionally, only if a certain condition is met. And you can do that in Angular by using the @if template syntax, which also, however, is only available since Angular version 17. Before that, you had to use the special ngIf directive, which was a bit more clunky to use, however, especially if you don't just have a if case, but also potentially some else or else if cases you want to handle. Also common is that you want to output some list data and you want to repeat some part of the DOM for every element in an array, for example. This can be done with the @for template syntax, which makes it easy to loop through all the items in an array and output some markup for every element in that array. This feature is also only available since Angular version 17, and therefore in older Angular versions you would use the ng-for directive instead. Other features we had a look at in this section were, for example, how to dynamically add or not add a CSS class to an element with help of that special class binding syntax. We also had a look at the special ng-content element, which is offered by Angular, which in the end allows you to define a slot in the markup of a template that will be used to render the content that's passed between the tags of that component, which can be really useful. And we also, for example, had a look at pipes, which make it easy to format and transform values you're outputting in the template. Like, for example, the date pipe, which can help with date formatting, another feature that's built into Angular. Another problem you commonly have to deal with is the submission of forms and how to handle that. And that's again a place where Angular helps you by giving you the special ng-submit event to which you can listen when using the forms module, I should say, which automatically prevents the browser's default, which would be to send an HTTP request to the server that served the website, which you typically don't want when building an Angular app, so that instead you can then handle the form submission in the client-side code, so in your Angular code, so that you have full control over how the form submission is handled. Well, and last but definitely not least, we had a look at services, which is another crucial concept in Angular. To be precise, it's the combination of services and Angular's dependency injection mechanism, where the idea simply is that you can outsource data and logic from a component into a service and then inject that service into all the components that might be interested in the data or some of the methods exposed by the service. You can inject that service by decorating the service class with the @injectable decorator, which in the end tells Angular that it should be aware of this service and that this is something you want to inject somewhere. And you then do inject it either with help of the constructor by listing the service as a dependency there, and it's the type annotation that's important here, or with help of the special inject function. And then the places where you injected the service can use the entire API of that service, which therefore makes sharing logic and data a breeze. So of course, this section contained loads of content. It was a huge section because there are many essential features you must be aware of. Now you can of course repeat that section as often as you want and as you need it, so that you make sure that you really have that solid foundation, but you will of course also see all those fundamental concepts in action again over and over again throughout this entire course in all the other sections and in all the other demo projects we'll build. So there will be plenty of opportunities to work with these essentials. And therefore, we're now ready to take the next steps and dive deeper into those different core features Angular offers and also explore some more advanced concepts throughout the rest of this course.